A thongophone is a percussion instrument made up of pipes, often constructed from materials like bamboo or PVC. It gets its name from players using rubber thongs or flip-flops to strike the pipes, producing various musical notes. Known for its deep resonant sounds, the thongophone was popularized by the Blue Man Group, who brought it into wider recognition. The group served as the initial inspiration behind this project. Our instrument was made out of cardboard tubes donated to Barron a couple years ago. We have 36 possible notes across 3 octaves, with each box being a single octave with 12 different notes. Each musical note corresponds to a specific frequency and has an associated MIDI number. The length of our tubes was determined by inputting the desired note's frequency into this formula on the screen. MIDI numbers are predefined as part of the Musical Instrument Digital Interface, aka MIDI, standard, which is used in the synchronization of electronic musical instruments with other devices for playback, editing, and recording music. Our project was to revitalize the interactive thongophone, which had become non-functional over the years due to various hardware and software complications as reported by the project sponsor. I am delighted to share that our extensive system overall has successfully eliminated all these issues. Here's a brief overview of how our system works. First, a MIDI message will come from either a file or the MIDI keyboard itself and be sent from our computer to one of our 3 Teensy 4.0 microcontrollers equipped in each box. It is the job of this microcontroller to then decode that message and send a signal to one of its output pins. Each output is then tied to one of our 12 solenoids in each box. This solenoid will then activate, hit the drum head, and force air through the tube. The length of this tube determines which note is produced and how it resonates. Each solenoid is driven by a MOSFET that is protected by a diode from destroying itself from back EMF. This is how the thongophone sounds playing a MIDI file as of today. Our user interface was created in Python with a focus on simplicity for teachers and students of all ages to interact with the instrument. It comes preloaded with works from famous composers that allows the user to select the song they would like to play. Once they've done so, they can hit the play song button to start playing on the thongophone. To turn it off, hit that same button. If live plays more your speed, hit the play button and start tapping on keys on the included MIDI keyboard. A user can also change how often the Westminster chimes play based on 4 different settings. One of our sponsors' requests was for the thongophone to mimic Penn State Barron's Smith Chapel chimes that students of the campus should be very familiar with. For those of you that don't know, though, the Smith Chapel is actually playing the Westminster chimes. The Westminster chimes is a melody used by many clocks to mark the passage of time. It features 4 sets of notes that play at each quarter hour, with each set progressively building in complexity until the full melody is being played at the top of the hour. To achieve this, we wrote a Python script with each of the changes and the times that those changes should be played. Here is the thongophone playing the Westminster chimes. For our last clip, here's the thongophone playing John Williams' The Imperial March from Star Wars: The Empire Strikes Back. To learn more about the Thongophone Instrument Modifications project, visit the Fazenmeyer Conference webpage to view our poster board and project summary. Thanks for watching.